So now we have the experiment set up. So the first device we're going to look at is called a function generator. And this is a digital function generator, so there are ways you can play around with the what's varying, how much it's varying by, and how it's varying. So you can set up a frequency or a period by hitting the FT button. So you hit that, and the first is F, the frequency. We're actually looking at slow variations, so we want to set it to period. And so then you enter the number 3, and then you look for the units that say seconds. So you hit that, and so you have a 3-second period. The SQR means you have a square wave. So, and the amplitude you have is 2 volts. So for 1.5 seconds, you have 2 volts. And for 1.5 seconds, you have 0 volts. Now, when there are 2 volts going through the circuit, the capacitor is going to charge. When there are 0 volts going through the circuit, the capacitor is going to discharge. So let's see how this looks. Looking through the red wire, you see we have it's connected to a capacitor. The capacitor is then connected to a current probe. Now the current probe is a Logger Pro device. So you see we have our lab4 mini there. And so it's going to be recorded onto the computer. We also have a resistor presently set to 500 volts. You want it large enough that you can see the charge and the discharge is happening over time, but not so large that the signal gets drowned out by the noise. And I'll talk about the noise in a second. And then from the resistor, you go back to the black terminal of the function generator. And so you have a complete circuit. Now, when everything is stable, you'll see something on the computer that looks like this. And when you get a spike, that's when it's charging. And notice it takes a little bit of time to charge. And where it's negative, that's when it's discharging. And so we have charge and then discharge and then charge and then discharge. So it's only set to 2 volts right now. So the charges aren't going to be all that big. So, but we need to be careful about measuring it. And I should warn you, you need to baby the equipment a little bit. Every so often it gives kind of odd looking readings. If you get an odd-looking reading, you just hit restart and try again. So what we're going to do, and you can also see that there's quite a bit of random noise here. And so you want to, the random noise will affect the variability. So what we're going to do is take 5 readings. And the magnitude of the charge and the discharge should be the same. But we're going to take 5 readings. And we're going to average them. So how are we going to do that? Well, the first thing we want to do is we only want 1 charge or 1 discharge. So we're going to go to experiment, go to data collection, and instead of 10 seconds, we are going to make it 1.5. So that should give us 1 charge or 1 discharge. And we are going to adjust the axis here, so that's also 1.5. So you click on the outer number, you'll get a box, and then you enter the new number you want to put in. So it's going to look something like that. So that's what you want to see. If you see anything that doesn't look like that, move on. So the next thing we're going to do is get the cat out of the way. And the next thing we're going to do after that is check that we're properly zeroed. So if you get a consistent non-zero reading when the circuit is disconnected, that means what you need to do is go to experiment and click 0, because you don't want any shift in your reading, or any positive bias or negative bias for that matter in your readings. So now we are reconnecting. And so we're going to do this one at a time. And again, if you get something that looks kind of ugly, just hit collect again and move on. So we'll try this once and see how it goes. All right, so that was kind of noisy. We should see one spike, and it may take a couple of times. Okay, so that we didn't see any. All right, so that might have been one, but we'll try this again. All right, so we got our one spike there. And so we got some noise as well. But ideally, the noise is going to cancel each other out, and you're just going to be left with that signal. So how do you... Now, we're reading current. So this is the charge flowing through as a function of time. Now, current is the derivative of charge, but to go from charge to current, you take the derivative. But to go from current to charge, to go back in the other direction, you take the integral. So we're going to integrate over this whole section, and it's giving us a negative number. So this was a little bit too noisy. So we're going to try this again. All right, so it looks like we got a charge at the end. So let's do the integral for this. And so you get 0.0005032 ampere seconds. And an ampere second is just a coulomb. So you're going to take that value, and what you're going to do is we're going to get 5 values. And we're going to average them. And then we're going to move on to 4 volts. So we're going to try this again. And so this is in coulombs. You're going to want to enter them in microcoulombs, or enter the average values in microcoulombs on your tables. So that way when you do the plot, you get a slope in microfarads. But let's move on. All right, so that was too noisy. All right, so that was good enough. And so you get 0.0005299. So that's your second value. All right, and that's way too noisy. All right, and that's too noisy as well. And so you see, you may need to be patient. You have to wait a little bit. And it looked like you were almost getting something, so maybe one more. All right. Okay, so we're going to go with that. So that's 0.0004040. And so we try again. All right, and that's too noisy. And it's likewise too noisy. So you should see either one peak or one drop. And if you get anything more than that, it's too noisy. All right, so that looks like the peak here. So that's 0.0006329. And one more at this value. Okay, so here we go. So 0.0003391. So, okay, so those are your 5 values. You're going to average them and then multiply it by 1,000,000 so that you get your average charge in microcoulombs. But now we're going to up the voltage, and the capacitance should increase proportionally. So you want the amplitude. So instead of going between 2 volts and 0, you want to go between 4 volts and 0. So you hit the amplitude button until you get a flat line, and you hit the number 4, and then you hit the units for volts. So now you've got a 4-volt amplitude going. And so the signal should be more obvious with this. So that's downward. So what you're going to do is ignore the negative sign and just go 0.0001760. And so that's what you're putting in. And then we repeat. right, and that's too noisy. And that's also too noisy. Sometimes he gets these surges, and I'm not sure whether it's the capacitor or whether it's the instrument. Okay, but that one looks like something we can work with. And so that's 0.002866. So we have that, and now we move on. Okay. So that's 0.0005079. That is 0.0009954. And one last one. And that's 0.0003439. Okay, so you're going to average those 5. And if you see one of your points looks like an outlier, again, there's quite a bit of random noise, but you should be able to at least see the linear relationship as the graph develops. So now we're going to adjust the amplitude to 6 volts. So now we have 6 volts going in. And okay, so unfortunately it got noisy at the end. So we can't use that one. All right, and that one got noisy. All right, so that one was right at the beginning. And so that's 0.002141 for that. And let's do another one. Yeah, we got the end of one and the beginning of the other, so we can't use that one. Yeah, so sometimes you have to be patient with this, but again, too much noise. All right, so that's what you want to get. And so that's 9.967 times 10 to the negative 5, which seems really, really low to me, and I'm not sure why. So what I'm going to do is discount that, and I'm going to check the offset again. So I'll unplug here. Yeah, so again, there's a bit of a positive offset creeping in. Okay, so reset that, reconnect. So we're going to start this over from the beginning for 6 volts. Okay, so that's 0.0004671. All right, we can't use that one. We can't use that one. And we can't use that one. like it might be settling down. All right, so that looks good. So that's 0007571. And we're back to this. You see, sometimes it takes a while to get a decent reading. So there was too much noise at the beginning. Okay, so that was nice. And that's 0008372. That's another nice one. So that's 0005778. Yeah, too much noise. Way too much noise. Okay, again, it looks like we caught the end of one and the beginning of another. So one more of these should be sufficient. Just have to be patient. That was almost good. All right, that's good enough. 0007113. So that's 6 volts. Now we're going to change the amplitude to 8 volts. And we're going to repeat the process. So we want to get 5. All right, so that was a nice one. 001090. That was another nice one. 001062. Almost good. That was another good one. 0009294. That's another nice one. 0009447. So these have actually been very consistent. And that's another nice one. 001010. So that's the 4th. And that's 8 volts. And now we're going to go to the maximum amplitude setting, which is 10 volts. Zero zero 1292. that's not good enough. There, that's a nice one. 001445. That was almost a nice one. That was a very nice one. 001230. That was too noisy. That was a nice one. 001318. And the last one of these. Not too much noise. And that's another nice one. 009364. And so that's the last one at 10 volts. And so each time you finish, what you're going to do is you set the amplitude to 0 volts. What that means is the capacitor, you give that a couple of seconds, and the capacitor is now discharged. And so you want to make sure the capacitor is completely discharged, so you turn the power off, and you then disconnect safely. And now we're going to move on to the second part.